Hey folks, today I'm going to talk about using SLOs at scale. Before I get started, let me quickly introduce myself. I'm Ashutosh Agrawal. I'm a principal engineer in CTO's office at Disney+Hotstar. So before we get into the subject, let me set some context, right? So Disney+Hotstar is an number one OTT platform in India. We have more than 45 million subscribers on our platform, and at peak, we have dealt with 25.3 million concurrent users. We stream both VOD and live content, various formats of entertainment, sports, and other genres as well. Another important element of our platform is the traffic, right? So, because as I mentioned that we are into the business of both entertainment and sports, so sports doesn't happen on all the days. As a result, the traffic really varies over the course of entire year, right? So there are days when there are sporting events, and our traffic platform peak would go in like upwards of 8 million at times. And then there are days when the traffic is completely silent. So we generally call days when there is a high peak or a high concurrency event as event days, and rest of the days are treated as non-event days. IPL is a format of an event days where we have continuous 60 days of peak traffic happening every day. Because of this sheer scale we deal with, right, both in form of traffic variance and the volume of subscribers we have a lot of challenges we have come across on using SLOs. So I just want to walk you all through some of those challenges. One, the biggest challenge we have is event versus non-event days calibration, right? Because of the differential behavior on event days, the platform calibration and baselining becomes really tricky, right? Especially for features which are actually active only on event days. So you've got certain features like scorecard, which is and social, which are actually only active during sports, and you don't have any baseline data when they're not active, right? So it becomes really tricky to set an SLO. And if you set an SLO, they will probably be breaching those SLOs because of the lack of traffic, right? Another important element I want to highlight because of the event days nature is that even if you might have an SLO of 99.9%, which allows you for a failure of 0.1%, but that 0.1% failure at a peak time during a sporting event can be really more catastrophic than it being scattered across the day, right? So it becomes very important for us to ensure that while we have 99.9% SLOs, but that failure should not happen at the peak hour, right? So it's something which can be bad for the platform. The other element which comes is that we have a lot of services and components on our platform, right? We have 1,000+ different moving parts in our system which run the entire platform. As a result, it's really important to be able to diagnose incidents much faster, right, and build correlation across components. Sometimes you have service one causing upstream issues, so you should be able to do a traffic comparison, latency comparisons across these services to be able to figure it out. The other important element is communication. As in any incident management, there is a lot of issues which happen due to communication. So it's important to keep all the parties informed. So if a particular service or component is having an impact, it's important to keep all the upstream, up in the chain people notified so that they're not coming back to you and asking a lot of irrelevant questions while you're trying to mitigate an incident. The third problem I want to talk about because of the scale of our platform is the global deployment setup, right? I know cloud has solved a lot of bunch of issues over there, but still no two data center is same, right? And because of a sheer volume of traffic we deal with, we have often seen data center degradations as well. So and we have what you have noticed that no two data center of any cloud provider is same as that, right? Within data center, their SLOs and their latency guarantees and the response times actually changes. So one data center might say that they have a network latency of 1 ms, but another data center might have 2 ms. So which causes a lot of overhead on the subsequent communication which is happening. So it's very important for us to able to manage the SLOs across data centers also. Cross DC interactions is another big pain point. When you're going from data center A to B versus you going from B to A, the response times and the network paths can be different. As a result, you need to calibrate your SLOs, and your SLOs need to factor in these kind of behaviors as well. So, what have we done about these, right? How do we deal with this kind of working with SLOs at scale? So, we started with a very simple dashboard. This is about like 3 year back when we were not using any hardcore platform for doing our SRE stuff. What we had was a very niche dashboard where we had these rows and columns. In individual columns are individual services and components, and each of the row was kind of layer of the service, right? So the bottommost layer was telling you the load balancer traffic, the above one was telling you the health of the pod, and the above that was telling you the health of the running application, and then you had some SLIs like latency and other metrics. So we used to use this to identify an issue on platform. Anytime there was an issue with any component, the respective block would go turn orange and then red, indicating that there is something wrong with that component. And then we would ask the respective on call of that component to take care and debug this issue faster. And to be honest, this has worked out very well. It was very sensitive. It was able to pick up signals much, much faster. But this couldn't scale for us, right? As we added more and more services, this worked very well when we had like 50 odd services. We had like 3 to 4 dashboards and you could look at it and we were visually able to monitor this. But as we scale and we grew into this domain of 100 plus microservices, thousands of different components, this is not working out for us. So what we started doing is we started looking for a platform where we could kind of bring all the metrics which you saw in the previous dashboard together, right? But in a different format, right? Like compress it a little bit and make it a little bit more intelligent. So our objective was that, hey, can we map out the entire service dependency into this graph and be able to visualize that how each service or each component is dependent upon each other, right? And if there is something wrong, highlight that component in red, right? And thus be able to figure out where the problem is much faster. And within a component, we want to do the same. Like within a component across different tiers or different layers of the component, what like from load balancer to databases to Elastic Cache or to caches that you're using, figure out anything. And to give you an example, right? So let's say this is a screenshot from a real incident, right? When this happened, you can see that, right? The incident happened on the service, and you can see that incident happened because of an Elastic Cache issue. And our ability to figure out, okay, this is the particular node which has caused an issue, actually helped in reducing the time we took to diagnose or to figure out what is causing the problem, right? So being able to have relationship within the services, bring focus to the component causing the SLO breach is what we are looking for, what we have built so far. What is our long-term objective, right? To be able to operate efficiently. So these are the 3 principles on which everything we build our SRE platform, right? Whatever we use. So we want to keep stuff top line. We don't want to bring all metrics, right? I don't want to get heap metrics, XYZ metrics from different applications and track everything under the SRE dashboard. While those are nice to have metrics, but I believe that the focus should be on leading indicators than trailing indicators. Leading indicators would help to identify the problem much faster. Trailing indicators are super helpful when you're doing an RCA. So the idea is to keep stuff top line, focus on leading indicators and this thing. And your SRE tool is not my debugging or tracing dashboard. Sorry. SRE tool is focused. My objective is that SRE tools help you identify where the problem is. Once you've identified where the problem is, you go to the respective tool and do a more debugging or a more deeper analysis with whatever the tool comes in form of the monitoring and etc. Right? So if there is a problem in a Kafka, you go to the Kafka dashboard and figure out the rest of the stuff over there. This tool is to keep your top line, be able to identify and tell you that, hey, this particular broker of Kafka is causing the problem. So then the other thing we want to do with our SLOs is that we want to apply the same principles on our business and product metrics also. Just not correlate our engineering metrics, but be able to correlate across business and product metrics as well. So imagine I'm having a degraded performance and playback API response time, and I want to figure out what is that impacting in my platform, right? So if I have this kind of a correlation, I can easily notify the respective product stakeholders and business stakeholders, and then they can channel the communication. Or the other use case I have is, let's say there's a dip in business metric, a particular business metric, right? And today what happens is that the business metric dip is figured out at the end of the particular reporting cycle, and the business team then comes back and asks what has happened. Now, at that time, a bunch of people get involved in investigating different things and doing analytical stuff to figure out where the problem is, right? But if we had this kind of correlation and visibility available across different layers, right, across business, product, and engineering metrics, you could easily come to this dashboard and be able to figure out, okay, this dip, this metric dip, what did corresponding to that dipped in the product layer, and then from there you can figure out what dipped in the engineering metrics, right? So that's the like holy grail of SRE in my mind, right? So our goal is like, and this would help in reducing a lot of operational expenditure which we incur, right? So reduce time spent on figuring out how did a particular change bring all impact us, right? Faster impact assessment, which will help us in keeping our customers happy as they would have to deal with an incident for a lesser amount of time. So yeah, that's all from my end. Thank you. Thanks for your time.